Okay, now we're recording.
So that whole first part's silent? The whole first part's going to be silent?
Yeah, but you can still see the screen though. It's just like silent movie. It takes a different way to appreciate it.
Oh.
just like the silent movies in the past.
Sure.
Except we don't have the caption screens to actually describe what is going on. Maybe I should add that to the first part of this lecture, just so that it looks exactly like a silent movie. Okay, so the first line is line 15. The first line to execute is line 15. And it does something that's really simple to track. It changes the value of x to 5. Then we go to line 16. And line 16 is an invoke statement. There are two things we have to do when we invoke a subroutine. The first one is what?
Return line.
We have to remember where we're supposed to go back to. So that means we have to allocate a new column. We have to allocate the leftmost unused column. In this case, it's column E. I just label that as return line number so that we know what this column is used for. And then we remember where we are supposed to go back to. Where are we supposed to go back to after the subroutine completes? Post. Post. Because we don't want to go back to line 16. If we go back to line 16, then we'll just be doing the same thing again.
Right.
Then it becomes infinite. So we want to go back to post. That's good. Okay. Now that we have remembered where we are supposed to go back to, the next thing we have to do is to continue execution in the subroutine. In this case, because I am invoking add 9, we have to continue execution on the first line inside the add 9 definition, and that will be line 9. Very good. Line 9 doesn't do anything particularly tricky. All it does is to put a value of 0 into I. Then we go to line 10. So once we're in a subroutine, the way we do things is the same as before. There's nothing really tricky here. I is less than 3 is true because I has a value of 0. Then we go to line 11. Line 11 is an invoke statement. Just because we are already in a subroutine does not change how we deal with this invocation. So we still have to go through the same two steps. We allocate a new column, the leftmost unused column. In this case, is column F. We label it as return line number, and then we figure out which line we're supposed to go back to. Since the invoke is on line 11, we have to go back to line 12. Okay. Now that we know where we're supposed to go back to, we continue execution in add 3. Add 3, the first line inside is line 2, and line 2 is initializing I to 0. Right at this point, you should have some doubts about this program already, because the two subroutines are using the same variable I. Okay, but it doesn't look wrong at this point because I'm just reinitializing I to 0. It was 0 before, so the effect was not that it will do anything that is wrong at this point. But it should, kind of trigger something in your brain, in your mind, that something doesn't seem right at this point. Then we go to line 3. Line 3 is evaluating the same condition as line 10. I is less than 3 is true. We go to line 4. X gets incremented from 5 to 6. We go to line 5. Line 5 adds 1 to I. I goes from 0 to 1. And right now, you should be thinking, oh, but isn't that the same I that add 9 is using to keep track of how many times to invoke add 3? And the answer is yes, it is. Then we go back to line 3. I is less than 3 is true because 1 is less than 3. Then we go to line 4. X gets incremented to 7. We go to line 5. I gets incremented to 2. Go back to line 3. The condition is still true. Go back to line 4. We add 1 to X. X becomes 8. We go to line 5. I becomes 3. We go back to line 3. The condition is now false. Okay, no big deal. This is exactly the correct behavior for add 3 because it did end up adding 3 to X. X was 5 before, it is now 8. After line 3, because the condition is false, we have to go to line 7. And line 7 is the end of a subroutine. which means we have two things to do again. The first thing we have to do is to look up the leftmost return line number column. In this case, the rightmost. The rightmost, or the most recently created return line number column is column F. It tells us that we have to continue execution on line 12. Okay, so now we remember we have to continue on line 12, but you also have to remember to indicate that column F is no longer in use at this point. So the way I do it is to use a strike through. So you go to Format, Character, and then select strike through and use single, double, whichever one you want to use is fine. I just have to indicate that this column is no longer in use at this point. Are we doing okay so far? This is all the same stuff that we have gone through on Thursday last week. Now that we're on line 12, what does line 12 do? Line 12 is simple. We just add 1 to I. Ooh, but I is now 3, so adding 1 to that, it becomes 4. Then we have to go back to the beginning of this loop on line 10. Line 10 is evaluating the condition. I is less than 3 is false. We get out of the loop. We get to line 14. Line 14 is once again a return statement. So if we look at the labels here, we have to look up the rightmost or the most recently created return line number. Column F is no longer an option because it is no longer in use. So we have to use column E in this case. It tells us to continue execution at post. And then we have to do the same thing because we have to say this column is no longer in use. And that's the end of the execution of this program. But when you look at the value of x, it only got incremented to 8 instead of 14. So this program did not do what seems like its objective. It did not accomplish that. And the reason is because there's only one variable I. Okay. Are there any questions about why this program did not add 9 to variable x?
Because add3 was inside the add9. So
Because they are sharing the same variable I. When add3 executes, it clobbers, it overwrites the value of I that add9 did not anticipate to be modified. Okay? So what is the solution to this problem? Local variables, that's the correct solution. But what are some of the more obvious but incorrect solutions?
changing the variable.
Change the variable, exactly. So one would use I, the other one would use J, and that solves the problem. Would that be a scalable solution?
No.
Why is it not a scalable solution?
You have to go through the whole program.
Sorry?
You have to go through the whole program and replace J and I and how
No, because the more subroutines you have, the more variables you have to have. So if you have 1,000 different subroutines, you don't have enough variables, you don't have enough letters to cover that.
That's okay. I can name my variables, I 1000,
But you
I
have to
1001. But then I have to remember, but I'm smart. Instead of doing that, I can say, make it add9_i. Make the other one add3_i. Prefix it with the name of the subroutine. Yep.
The problem with that is that when you begin the execution of the program, it assigns
It allocates all the storage.
the storage, right? For
Right.
each one of those variables, as opposed to using local, it's only on an add-needs basis.
Right. What he's saying is, we have to pre-allocate. If I use, add3_i, add9_i, I will have to pre-allocate all those columns ahead of time. If I had 1,000 subroutines and each one has, 20, variables, then I'll have to allocate, 20 times, 1,000, columns just for, the variables. But you know what? That's not even the biggest problems that I have. It is a problem, especially when you're running low in terms of memory. But these days we have 4 gigs and 8 gigs of RAM, so that's not a big issue. The big issue is, what if I have a typo? In other words, I have a typo. Let's say in add3, I accidentally typed, instead of add3_i, I accidentally type add 9 underscore I. Would the tool be able to say, tag, this doesn't look right? No, because it is a variable. A variable is a variable, and it can be used anywhere in the program. But the program would not behave correctly anymore, right? But the worst part is not even that the program would not work correctly anymore. It's hard to find because the symptom may not appear in add3, because add3 is clobbering somebody else's variable. So the problem or the symptom can appear like a lot of lines in the trace later. So by the time it reappears, I would not have any idea of how it happened. Who changed my variable? Well, as it turned out, it's some other subroutine, and someone had a typo, and therefore one of my variables got clobbered. Okay, that is the biggest problem with global variables. It's really hard to keep track of who should be using what and who it actually is using what. So the solution is local variables. Let's go ahead and save this one last time for the wrong version, and then we'll save it as another name. And some of you can probably guess the name of this new file, good local variable. You will hear this multiple times from me. If you can avoid the use of global variables, you should. Okay, you can even add it to your, well, I shouldn't say that because that's just not right. But you should remember, global variables are evil. Okay, they're just evil. They're evil not only because they can cause problems like this, but because there are times that you will be tempted to use global variables. It just seems so much more convenient to use a global variable for blah, 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 blah. Okay? It just doesn't scale up. You just pay later when you use global variables. So we'll keep that in mind. Most of the time, stuff like that I talk about, you probably won't experience that unless you're writing programs that are at least 1,000 lines long. Which means, for any type of school project that you do here, you won't run into those problems. You can use global variables and never experience a single problem that I mentioned. But that's only because the program is relatively small and you are the only one writing that program. But when you have to collaborate with other people, with a program that is hundreds of thousands of lines long, which is actually considered a fairly small program by any standard, then you can run into problems with global variables very easily. Okay? So some of these problems we cannot really experience when your project size is too small, but nonetheless you should keep in mind that global variables are bad news. Definitely try not to use global variables. All right, now we want to fix this program. Let's get rid of this one first because we have to change the code first. To change the code, I'm going to add one line here, and all that line is saying is local I, which means I is no longer a global variable, but now it is a local variable. And I'll do the same thing here. Even though it is not necessary to make both I's local, it is just a better way to do it. Okay? So it is a good time to differentiate what is global versus what is local. A global variable means everybody can see it. Anywhere within your program, within any definition of any subroutine, it is still accessible. Okay? It's kind of like a single stapler in your office environment that is out there in a shared area. Anybody can go out there and use that stapler. A local variable is completely local to the subroutine. In other words, on this line here, it doesn't have a line number because I'm not going to trace that line anyway, so it does not really require a line number. This I is only visible within the subroutine add I. When I refer to I inside add I, like on line 9, line 10, and line 12, they are all referring to the local variable I that I declare on line 10. So by the same token, when you look at add 3, when I refer to I on line 2, line 5, and line 3, they are all referring to the I that I declare on line 2. That's the trick. Okay? We are limiting the scope of the variables. Okay? A variable is now only visible within the subroutine that contains its declaration.
Would it be wrong to have that be a line?
Hmm?
Would it be wrong to have that be line 2?
We can just renumber these things, because there's no need to. So now we can say line 2 is the declaration. The declaration really doesn't do anything. All it does is to tell the compiler or the interpreter that, oh, by the way, this subroutine needs a variable called I, and only this subroutine should be able to access that variable. Yep.
How do you get C to break it out? Like, do you define a variable?
In C, all you have to do is to say int I inside the curly braces of a function definition.
And then even if you have int I in the main program, it won't.
That will hide the global. The local variable will override it will hide the visibility of anything that's global. That's a good question.
So if I have int I in the main, and then in the subroutine I do int I, and the main's variable is 3, we'll say, and then the
It is
local
hidden.
variable is 4. Even
That's-
after the subroutine is executed, it'll still go back to 3.
Yep. Okay, let's take a look at this program. Okay, just to add a discussion. Line 17 is outside of the definition of any subroutine. You cannot have a local variable unless you are in a subroutine. Okay? So that means the I that I refer to on line 17 has got to be a global variable. So now we have a case of massive confusion, right? Not only do we have 2 local variables called I, but we also have a global variable called I. So the question is, when I refer to I on line 11, when I refer to I on line 3, which variable am I referring to? And also, how does the computer keep track of all 3 variables at the same time? So all of those questions will be answered when we trace this program. Question?
Yeah, what are the curly braces when you say int I inside? What does
Oh,
that mean exactly?
well, he was asking me a language-specific question. He
Right.
was asking me about the C programming language. In the C programming language, I refer to this as a curly brace. I'm pretty sure it has a much more formal name.
Oh, it's a curly
No, that
brace.
is what it's called.
That's what it's called?
Oh, okay.
A lot of people just call it a brace.
A brace. But then becomes kind of ambiguous because you have the square brackets too.
Yeah, those are just called brackets.
I just make it very clear so that there's no confusion. Yep.
So with local I, do you have to put anything that says not in local I, meaning that I goes back to the global value? Or is it
Nope.
just once the
Nope.
subroutine's over?
No, there's no need to do that. So when we trace the program, it will be clear how things are tracked. Okay. I might need to change the amplification of the mic a little bit, just pump it up a little bit. All right, so let's go ahead and take a look at this code and look at the trace, because the trace is the important part here. When you look at the changes to the source code or to the pseudocode, it doesn't seem very significant. I added only 2 lines to say that I is local. So that's not very helpful. What is really helpful is going to be in the trace itself. So let's go ahead and change the trace. And you will find that even the way I set up the columns will be, well, actually in this case I cannot change it too much, so I'll still need the same columns in this case, because I changed it a little bit from the original form. Okay, we need comments because we have conditions to evaluate. We have line number. We have x, because x is definitely a global variable, because it is referred to outside of any any subroutines. And also in the subroutines, x is not declared as local, so that means it has to be global. Okay, but we also have I here, oops, because we have line 17 referring to I, and line 17 is outside of the scope of any definition of any subroutine. Okay. Same, precondition is we don't need to know anything about x or I. We start execution on line 17 in this case. The global variable I has a value of 25. And then we move on to line 18. X gets a value of 5, and then we move on to line 19. Line 19, just like in the previous case, is an invoke statement. We still have those two steps to follow. The first step is to reserve or allocate the leftmost available column and to remember where we are supposed to go back to. In this case, we're still going back to post, just like last time. And the second step is we have to continue execution in the subroutine, in the first line of the subroutine. In this case, it is line 11. Local I does not execute, so we don't track that line. But then there's one more thing we have to do. Okay? Because I on line 10 is local, that means it only starts to exist when the subroutine is invoked. Okay? So that's another interesting attribute of a local variable. Not only is it visible only within the definition of the subroutine, but it does not even exist until the subroutine is invoked. Are we doing okay so far? So in many ways, sorry? It saves memory, and therefore it saves memory because now it doesn't use up any column until the subroutine is actually invoked. So you can kind of imagine your program having, let's say, 1,000 subroutines, which is a fairly small program. Let's just say that by the analysis of your calling, the invoking of the subroutines, you understand that the deepest call is only about 5 levels. In other words, subroutine A calls subroutine B, calls subroutine C, calls subroutine D, calls subroutine E. But the 5 levels is the deepest you can ever get. So that means the worst case in terms of memory allocation is that you only have to allocate memory for those 5 invocations of subroutines. Even though you have 1,000 subroutines, you don't have to pre-allocate any storage for the local variables for all 1,000 at any particular time. So it does save memory. But this is called the lifespan of the local variable I. It does not even exist. It's not created until the subroutine is invoked. Have we seen anything like that? Something that does not exist until a subroutine is invoked? The return line number.
Return line.
Exactly. So from the perspective of allocating and deallocating, a local variable behaves somewhat similarly to a return line number. But you still have to remember, when you first create local variable I, its value is unknown. Now this part, someone can argue and say that, but that's not true, because in Visual Basic or in Perl or in PHP, when you first declare a local variable, it always starts with a particular value. It can be called nil or null or some other form, but they have some sort of predetermined state. But that's not the case in C. When you write a program in C and you use a local variable, it has a value, you just don't know what it is. So it is very important that you make that safe assumption that when you create a local variable, it is not 0. It does not start with any particular value. It's a question mark. Okay? Do we have any questions at this point? We have column D and column F both being I. One is a global variable, one is a local variable. A local variable hides a global variable. In other words, the global variable is no longer visible within the subroutine add line because it has a local version that has the same name. Are we doing okay so far with this? So you can have global variables of the same name, but if a subroutine has a local one, then the local one takes precedence. And that's why when we track line 11 and we put a 0 into I, we are no longer referring to column D. Instead, we are referring to column F. So column F is the one that gets a value of 0. Any question about this step? Because this is a important step because it differentiates the behavior of, or it tells you what to do when you have a global and a local of the same time, of the same name. We're doing okay with this? Okay. Then we move on to line 12. Now line 12 is the same thing. It is accessing variable I, but because line 12 is a part of add 9, when it refers to I, it is referring to the local variable I, column F, and not the global variable I of column D. So when we compare I to 3, we're comparing column F, which has the value of 0 to 3. 0 is less than 3 is true. We go to line 13. Line 13 is an invocation of add 3, so we have to go through the same motions again. First of all, we have to allocate a return line number column. And remember, after this is done, we have to go back to the line after the invoke statement, which is on line 14. And then we have to remember, when we continue execution, we have to continue on line 3. But at the same time, because add 3 has its own local variable I have to allocate another column for this local variable I. And once again, it starts with an unknown value. Are we doing okay so far? So this is telling you every time you invoke a subroutine that has a local that has any local variables, you have to allocate space for those local variables whenever the subroutine is invoked. All right, so now we resize the columns a little bit. We continue execution onto line 3. Line 3 says, yes, go ahead.
Good question. If we have localize more than one variable, can we just put like, if it was, for example, we want to do I and C, would you say local I and C? Or we should do local I and down to line local C? Does that matter?
You mean combining these two versus having them on separate lines?
Well, if we had two, we're gonna have two local variables.
Oh, then you just say local I, local J.
Okay,
It doesn't really matter if you use a comma. You can separate, and say local I, comma J, comma K.
Okay, so
As long as it's clear to me, it's fine.
Oh.
It's only pseudocode. It's not really that important. But I always use just one line for each variable, so I can refer to the declaration line. Okay. So right now we have 3 variable i's. We have the global variable I of column D. We have the local variable I of add 9. And then we have the local variable I of add 3. So the big question now is on line 3, which says I want variable I to get a value of 0. Which column should I be changing? We should be changing column H to 0. But what about column F? What about column D? They're not visible anymore because a local variable is visible only within the subroutine that contains its declaration. So that means this local variable I of add 9 is not even visible in add 3. If I did not say local I here, which variable I should it be accessing?
Global.
It will go back to the global because the other one is not visible.
So then you're out of technically you're out of subroutine 9.
We are out of subroutine 9. We save the state of subroutine add 9 so that when we get back to it, we can continue to do what we were doing before. But at this point, because my execution point is on line 3, we are officially out of the scope of local variable I of add 9. It's not visible anymore. Are we doing okay so far? Yep, go ahead.
The answer is probably yes, but do any subroutines do that in major programs? Like
They all
say,
do, yes.
One uses the global and the other uses its own local?
No, well, remember what I said, global variables are evil. So properly written programs will not have any global
Oh,
variables.
really? All right.
It would have global constants though.
You can do global constants, yep. Because constants cannot be modified. So you don't run into the danger of a subroutine modifying somebody else's variable. So constants are kind of like an exception to the rule because of the read-only nature. Okay. Are we doing okay so far? Up to row 11 of the trace. Then we move on to line 4. Line 4 is comparing I to 3 again, but once, because we are in subroutine add 3, and add 3 has its own local variable I, we have no choice but to use column H to do this comparison. 0 is less than 3 is true, so at this point it's fairly boring until we get back to the other subroutine. So on line 5 we add 1 to x. X is global, so we are still accessing the same x throughout all the subroutines. Go to line 6, we add 1 to I, so it's column H that gets incremented. We go back to line 4, the condition is still true. Go back to line 5, we add 1 to x, whoops, it becomes 7. We go to line 6, we add 1 to I, column H is now 2. Go back to line 4, the condition is still true. Line 5, we add 1 to x, x becomes 8. We go to line 6, it adds 1 to I becomes 3. We go back to line 4, I now has a value of 3. 3 is less than 3 is false. We get out of the loop. And let me change this part a little bit here so we can scroll that. Since the condition of line 4 is false, we have to get out of the loop. Then we end up on line 8. Line 8 will do about the same thing as before, except it has to do something else now. Okay, let me just show this part here. Okay. Do you remember what we usually have to do by the time we get to the end of a subroutine? We have to do the two things. One is to look up the most recently defined return line number so that we can continue execution there. The second thing is to deallocate the return line number column so that the column can be used again later on. But local variables behave the same way in terms of allocation and deallocation. So this time, since we allocated two things, columns G and H initially, we have to deallocate both of them. First of all, we look up this column and say, oh, we have to continue execution on line 14. Okay, that's easy. But the second thing we have to do is to say both of these columns are now deallocated. So we have to use format character on both of these. And I can't do it at the same time, unfortunately. Like so. So now I have just marked column G and column H as deallocated. They're no longer in use. We continue execution on line 14. Line 14 is just adding 1 to I. What am I supposed to do here? Which column is going to be incremented?
F.
Column F. Very good. Because we are now back in add 9. Add 9 has a local variable I, and it is using column F as a local variable I. So this is now incremented from 0 to 1. So this time the program is right. Okay? Because the local variable I of add 3 does not clobber the local variable I of add 9. They have exactly the same name, but they are completely different entities. Is that okay so far? Okay. I know this looks kind of boring, but I have to go through at least one more iteration. After line 14, we go back to line 12. I, which has a value of 1 at this point, is less than 3, is true. We go to line 13, and we invoke again. What are we going to do this time? Yep.
Go to column G and do a return line.
Exactly.
14 or whatever.
Exactly. In fact, I can be lazy and just copy and paste it, because we have to do exactly the same two things, or 3 now, because we have to remember where we're supposed to go back to, and also allocate another column for the local variable of add 9. then we can go in and do it again. So let's finish this part, because it will show you the importance of not making assumptions regarding the initial value of local variables. So we go back to line 3, and line 3 is what is it doing? It is reinitializing column H to 0. Okay? And that's very important, because we do want to reset the counter to 0 so that we can count to 3 again. Are we doing okay so far with this sample program? Are there any questions about the scope of a local variable? The scope of a local variable is within the subroutine that defines or declares the local variable. Nowhere else in the program is that variable even seen. It's not visible elsewhere. That's one thing. And then the second thing is the lifespan of a local variable. It does not exist until the subroutine is invoked. It disappears, it is destroyed as soon as the subroutine returns. Just like the return line number column. Are we doing okay so far with this? Okay. So let me save this. I'm not going to continue with this one because it would just be kind of boring at this point.
So once you added the subroutine, then that subroutine I can never be referenced again.
That is correct. Because once it is destroyed, if you see something like this, the strike through, that means, not only is the variable not visible anymore, the storage is also deallocated. Once you deallocate the storage of someone or of some variable, the content at that column is subject to change. In other words, at this point on row 27 of the trace, I can no longer assume that column H has a value of 3. Because once it is deallocated on row 22 of the trace, anything can happen to that column. Okay. So if this one is okay with you guys, let's go ahead and use recursion, but do recursion with local variables. Do you remember what is recursion? No? It's a subroutine that invokes itself. Okay, so let's go ahead and see what we're going to do this time. So I'll say define sub. Let's call this weird. This is by no means weird, compared to other sample programs that we will go through, but we'll just call it weird. We have a local variable I here, and we'll say I gets the value of n. Whatever n is a global variable in this case. And then we'll say if I is greater than 0, then we'll say n gets n minus 1. And then we'll go invoke weird. When it comes back, we'll say r gets I times r. We'll say and if, and define sub. And outside of the definition, we'll try to do something with this. Oh, I missed one thing. We'll say else r gets 1, and if, and define sub. And over here, we'll say n gets, let's say 3, and then we'll invoke weird. All right. This is our program. Do you guys want indentation or not? Yes. I hope you guys start to realize the importance of indentation, because without indentation, you can still kind of read the program, but it gets a little bit harder to match the beginning and the end of constructs. So, but once you have indentation, it's a whole lot easier. Just like that. All right. Yep.
What about R?
What about R? That's the interesting part. I did not seem to initialize the value of R, and yet the program will work correctly. So we'll figure out what it's going to do, because it is going to do something that is kind of interesting. And we'll call this.
Weird.
Name it weird. Yes. Okay, so we have weird. That means, in the future I have to name my subroutines weirder, even more weird. It's kind of like Doctor Who regenerates, right? All right. The most important part about tracking a program like this is do not overthink it. Okay? Just follow the basic mechanisms that we have talked about up to this point. Even though it seems, hey, do we really want to do this? Well, but since we did it with a simpler example, we should follow the same mechanism. That's the key to get this done. Okay, so we have comments, because we do have one conditional statement here. We have line number. We have two global variables. We have n as a global variable. We also have r as a global variable. The reason why I know r is a global variable is because r is referred to inside the subroutine, and yet I did not declare that as a local variable. So it has to be a global because it's not local, and yet it is referred to. But this is just the way we do pseudocode. In C, you cannot do it like this. In C, if you try to use a variable that has no declarations whatsoever, the compiler will come back and say, hey, I don't know about this variable. You have to say, this is a global variable, this is a local variable. You cannot leave it implied. In precondition, you know nothing about these two. And then we go to line 12. The first line that is outside the definition of any subroutine is line 12. N gets initialized to 3. We go to line 13. By now, we should know what to do at line 13. We have to allocate one column for return line number. And since there's nothing after the invoke statement, the return line number is post, just like with the previous example. And the subroutine weird has a local variable. So we have to allocate the storage for the local variable when the subroutine is allocated. No big deal. We have done this before. So we will allocate column F for local variable I of weird, which starts with an unknown value. Do we have any questions at this point? Up to this point, this is exactly what we did in the previous sample program. Nothing has changed. Then we continue execution in the subroutine, starting with the first line that actually does something, which is line 3 in this case. It copies the value of n, which is column C, to I, which is column F. That's not too hard. We just copy the value. Then we move on to line 4. Line 4 is pretty easy. I is column F, has a value that is greater than 0, is true. We move on to line 5. It changes the global variable n from 3 to 2. And then we have line 6, which is our recursive call. What am I going to do here? Well, same thing that we do whenever we invoke a subroutine. Well, certain things we know for sure already, because last time we talked about the recursive subroutine already. So we know, we just have to allocate another column for the return line number. But this time I have to remember the line that is after this particular invoke statement, which is line 7. No big deal. We know how to do that. And then we know that we have to continue execution in the subroutine from the beginning, which is line 3 in this case.
Isn't it going to?
But we also know that we have to allocate the storage for local variables. So now there are two options. One is once it is allocated, we just use that. The second option is for every invocation, we allocate again. And it is the second option that applies. Okay? So this means every time you invoke weird, in this case, you have to allocate for its local variables. So now we have to allocate another column, which is column H in this case, as local variable I. And once again, it starts with an unknown value because it is a local variable. When we continue execution on line 3, we're copying the global variable n to local variable I. Yep.
So for the line G, that on
Column
line
G,
H,
uh-huh.
or that local variable, is it the same as line F, or are there two different local variables? Because
Very good. That's the question is the local, I think you meant local.
Local, yeah.
Is the local variable I of column H the same as the local variable I of column F? That's the question.
So yes, it's on the original.
That's a very good
there's
question.
only one local variable.
The answer to that is local variables are specific to a invocation. So that means column F, which is global variable I, is specific to the first invocation of weird. Column H, which is also local variable I, is specific to the second invocation of weird. But you can only see the local variable of the latest, the most recent invocation. So when I execute line 3, I can only see column H, but not column F, because column H reflects what I should see in the most recent invocation, the current invocation of that subroutine. That is a very, very good question. Yep.
That raises a weird question. Okay, is there any?
It's okay, it's all weird. Yes.
Are there any subroutines that borrow a local variable or the value of a local variable from another subroutine?
You
Or is that
can,
too
but you can
crazy?
only do that using a mechanism that we have not talked about so far.
Right.
But the answer is yes, you can make a local variable accessible by another subroutine. But we have not talked about that. It's called a parameter. To be more specific, it's called a pass-by reference parameter. And that's the only way you can say, oh, here's my local variable, and you pass it on to somebody else and say, if you need to change it, this is what you should change. But we haven't talked about that yet, okay? But that's a good question. I think we'll talk about that probably in 2 weeks or so, because we have the exam, and then after that we have to talk about the solution of the exam. Yep. Sorry? I did not bring a row sheet today, so
And
we're
then
good.
also, I was wondering, is that viral, right? I think he was talking about. I think that's what it was.
What he talked about, what he wanted to accomplish, can only be done by a by-ref parameter.
Oh, okay.
Yep. So we'll talk about that later. Yep. So when we're back to line 3, when we compare I to 0, we are no longer comparing column F to 0. Whoops, excuse me. This is line 3, which is the copying. So we copy the value of n, which is now 2, not to column F anymore, because it is a previous invocation. We now have to deal with column H, which is the current invocation. So column H is the one that gets a value of 2. Then we move on to line 4. Line 4 is using column H for the comparison, which is 2. 2 is greater than 0 is true. We go to line 5. So by this time, we kind of know what we should do with line 5. We just subtract 1 from n. N goes from 2 to 1. And then we move on to line 6. Line 6 is another invocation. So we know that we have to do about the same thing here. We have to allocate one column for return I number. We have to allocate another column for local variable I, which starts with an unknown value. And then we continue execution on line 3. Are we doing okay so far with all of this stuff? Well, the question is, have I really changed the way we deal with local variables from the beginning of the class? Well, what I did was to clarify what happens when you have a subroutine that calls itself. Do we allocate additional storage for local variables? And the answer is yes. Okay? And we also make it very clear that these things, column E and column F, is specific to one invocation of weird. Column G and H is specific to the second invocation of weird. Column I and column J are now specific to the current invocation of the same subroutine. So we go to line 3, we copy 1 to I. We go to line 4, we compare I, which has a value of 1 at this point. It is greater than 0, is true. We go to line 5, n becomes 0. We go to line 6 for the last time. And we have to go do exactly the same thing. We allocate 2 more columns, like that. We know that we have to continue at the beginning of the subroutine, which is line 3. N is now 0. So on line 3, I also gets 0, but that's column L at this point. We go to line 4. We compare I, which is column L, which has a value of 0. 0 is greater than 0 is false. We have to go to the else, because this conditional statement has an else. The else doesn't really do much. It just says R gets a value of 1. So on line 9, the global variable R now gets a value of 1. And that's why I did not initialize it outside, because it doesn't need to be. So let me do this trick here so that we can refer to different portions of the program. Or the trace, I should say. Okay. After line 9, I'm done with the subroutine, or this invocation of the subroutine. I get to line 11. Line 11 is the last line of the subroutine, which means I have to do the cleanup. But before I do any cleanup, I have to look up the most recently allocated return line number. It tells me we have to go back to line 7. Okay, we'll go back to line 7. Then we can say that these 2 columns are no longer in use. So we have to kind of cross them out to indicate that we have deallocated these columns. I should define a macro to do this. Let's see how we can do that. Macros. Oh, I cannot record. I'll deal with that later. It doesn't have a record macro feature, which makes it easy. There you go. Now we're back to line 7. What am I supposed to do on line 7?
Go to the I in the third invocation.
Line 7 says I want to compute the product of I and R. So the question is, which I am I talking about? Okay, so let me show you this portion here, and then you tell me which I I'm supposed to deal with on line 7. Which column?
J.
Column J, yep. Because column L is now deallocated. I cannot consider that particular column. So when you go back, you always use the rightmost part of the columns as your context. And column J, over here, is the rightmost context available at this point. So that gives me the context to continue execution on line 7. Line 7 says I want to use I and R. I has a value of 1. Was it 1? Yep. It has a value of 1. And R also has a value of 1. 1 times 1 is 1. I put 1 back into R. Doesn't seem to be very useful, but that's what I do in this case. Then we get out of the conditional statement onto line 11. On line 11, we do exactly the same thing. We have to look up the most recently created return line number. It tells me to continue execution on line 7, and then I can deallocate those 2 columns. Just like that. So my context is now back to column G and column H, because I and J are now deallocated. The columns are still there, but I should not use them because they're now deallocated. Line 7 says I want to compute the product of I and R. I is now referring to column H. It has a value of 2. R is a global. Column D has a value of 1. 1 times 2 is 2. I store the 2 back into R. And then I go to line 11. Same thing. I look up return line number. It tells me to go back to line 7. And then I can deallocate those 2 columns. When we're back to line 7, I have to do this again. I have to find the product of I and R. But this is now deallocated. Everything from column G to column L are deallocated. So that means when I refer to I have to be referring to column F. Column F has a value of 3. R has a value of 2. 2 times 3 is 6. So I store 6 back into R. I get out of the conditional statement. I get all the way to the end of the subroutine. And once again, I have to look up the most recently defined return line number. But remember, column G, I, and K are now deallocated. So column E is the one that tells me where to continue execution. It is post. And then I have to remember to deallocate those 2 columns. Those 2 columns are now deallocated. I continue execution at post. I'm done. Are there any questions about this trace? It is simple in a way because it's the same mechanism of invoking a subroutine. It's the same mechanism of allocating storage for local variables. But in a way, this is also kind of strange and can be confusing because at any particular point, at many points of this trace, we have multiple i's, in the columns. But you just have to remember, we only refer to the rightmost part of those columns, and then we know exactly which I we should be using. And by the way, what am I computing here? What is R? How does R relate to N?
Factorial. Factorial.
It's factorial. Very good. R in this case is N factorial. If you specify N to be 4 to begin with, R will become 24 because 4 times 3 times 2 times 1 is 24. Okay, and so this program, all it does is to compute the factorial of N. Are there any questions about this program? No questions? So everything up to here with local variables will be part of the scope of the next exam. We will have a practice exam on Thursday. You should study as much as you can over the weekend and bring back any questions that you have on Tuesday next week so that you have one last chance to ask questions about those material. Yep.
Is there any site online that might have some of this stuff, or how do you find a square root, like in a little program?
If you're talking about how to trace a program, I have not found anything that has this type of representation of what happens inside your computer when you're executing a program. If you're talking about the algorithm, yes, if you look up factorial on Wikipedia, it shows you the pseudocode for that. However, it's going to use parameters, which we haven't talked about yet, so it's not going to do you a whole lot of good at this point. Later on, once we have talked about parameters, it'll be useful. Okay. Yep.
I was wondering if you can post like a question or like a problem from like each section that we learned, like one question from each section we learned. So when we do it, so we know if we know it or not. So later on practice test exam, we could actually you question like if we know how to do it or not. So it'd be easier for us to study.
It's kind of what I'm planning to do with the practice test is to give you, sample questions, that will reflect the scope of the exam itself. So, but you want it before Thursday. That's basically what you're saying. Okay, I can.
Just so we can know if we can do it or not.
I will see if I have time to do that. I might be able to do it.
Yep. So the questions are not posted yet.
The questions are not posted yet. Is there anything posted at this point? Exam 2 questions. That's a zip file. Well, let's take a look at this one. Yep, it does. So let me just quickly check, what these look like. The reason why I have to take a look is, I may not get to the same point last year or last semester when I had exam 2. So the scope of this exam may be too small or too much, relative to this class. So that's why I have to take a look first. Okay, make sure save this one first. Let's extract this to. I was hoping that I can explain, why factorial is important. We already encountered factorial once when we talked about the intractable problem, the number of combinations of the paths. But it turns out to be very important too when you have to decide, the jackpot is $7 million with Lotto. Should I buy one of those lotto tickets or not? Because because you can compute your probability. What are your chances of winning, and is it worth it to do it? So we can talk about it, when we have time to talk about that. I think that's a practical application of mathematics and statistics, and the answer is in most cases, no, it's not worth it.
It's not worth it.
Because you have to combine, not only statistics but also, taxes on top of everything else, and how many people may end up with the same number, and that you have no control over. Maybe 10 people have the same exact number, and you all win the jackpot. Let's see.
I split a jackpot 10 ways. I split a jackpot 10 ways.
But how many tickets do you have to buy, and what are your chances of winning, given that you only bought one ticket? That's the question, right?
To increase your probability?
Okay, this one definitely is within the scope of this class. We have talked about this already. It's just that, it's harder to read. I just have to change the sizing of the columns. Let's take a look at number 2. Number 2, we definitely can do. Doesn't involve anything that we have not talked about. Number 3, yep, just arrays and stuff like that. And here's number 4. So those questions in the current question 2 exams, they are definitely within the scope of this exam. But on top of these, we'll also add subroutines and local variables. So that's kind of like the minimum scope of this test. There'll be additional questions on top of those. Yep.
These are just for our own recognizance to do them at home.
Yeah, go ahead and do it at home, and we'll talk about these on Thursday. Just pick one of the variants, because I know there are multiple versions of each question. Just pick one.
You guys are advanced series solutions?